Okay, so let me go through the first most important idea about how to deal with overfitting problem. The first solution that you can come up with is the data splitting. And how do you do that? Basically, you have a data set and you split the data set into test data and training data, right? So for example, this amount, so for example, 70% of your data, you make that training set. That means you use this amount of data to build your model, right? And then you have the test set. That means what? You use this amount of data to test how good your model is performing. So basically, you are using the covariate values here, but in here you do not care about those covariate values too much. You just care about what is the difference between your y and the predicted y. Okay. To do this, all you need to do is within the caret package, there is a function called create data partition. And within that create data partition, you just say what is your y, the length of step, the original variable that you have. You mention the proportion, what proportion you want to have for your training data. And whether you want that data in a list form or not and stuff like that, that you can also specify. So just to give you an understanding, and remember that what we are doing here is that we are saving this as a split, right? And what we are doing here with the dimension of split is that 70% of the original data is slightly above 4,000. Right? We originally had more than 5,000 data, and 70% of the data would be slightly more than 4,000. And 30% of the data would be slightly more than 1,700, right? So when we split the data, you see the training data was slightly more than 4,000, and test data is going to be slightly more than 1,700. Notice that the numbers are exactly not the same. Remember, that was 1,720 and this was 1,718. So there might be some variability, but generally speaking, the proportions are going to be will be the same in this scenario. Okay, so sorry, what is going on? What we are doing here is that now we have created two parts of the data. One is the training data, one is the test data, right? And this is the test data part. I just named it test data, not so original name. I have the train data where I'm saving my training data. What I'm basically going to do is I am basically going to feed the same regression model with the same formula. I have not changed the formula. But instead of the observed data or the analytic data, I'm just going to use the training part of the data. Nothing more. And here I have a hand-coded formula or function of how to create a function that will give you the R square adjusted R square RMSE and all of that. So this is just a hand-coded formula that I'm showing here. And this shows me that when I'm using the training data to build my model, and again, when I'm using the training data to get the performance measures, I'm getting these numbers. The R square is 0.08. See, slightly more than before. Adjusted R square is 0.06. And RMSE is 24. Remember that this is happening on the training data, on the same data where we build our model. Okay. So when we use the test data to get our R square, see this R square is lower than the previous R square. This adjusted R square is lower than the previous adjusted R square, and this RMSE is now higher, right? And generally speaking, you are like when you are testing out all of these different measurements, you are getting lower value, and The higher RMSE means worse the value, right? So basically, in all of these settings, you are getting very similar understanding of what is going on. Now let's do something in between. What is that in between? We have built our model using the training data, but let us use the whole data, where 70% of the data was used to build the training model and 30% was not. Then you will get some R-square value that is actually in between those two extremes, right? Some adjusted R-square value that is in between those two extremes, the RMS value that is in between in these two extremes, right? So that kind of gives you some sort of empirical proof of the understanding that some sort of overfitting was going on. Unfortunately, our model was not so great to begin with, so you are not seeing a great difference between this R-square from the test or training. But generally speaking, even if you have a good model, this is always most of the scenarios this will happen, that when you are using one data to build your model and using another data to test your model, you basically will get reduced performance in terms of your performance measure. All right.